Hello, my name is Andrei Kulikov, and in this video I'd like to continue talking about visualization, and I'll do it of GRIDSEARCH, and I'll do it in CATBOOST. So I'm loading the data set, then do some manipulations to multiply the target values to make the targets balanced, and later I'll show alternative ways to do it. It's interesting also. So then I check the number of targets. They're nearly equal. Then I make test and train data sets, and then some comments concerning objects, but I I don't have categorical features, so it's for future experiments. And then I load this code where I shall use the following things. I shall use the pipeline parameters, uh, like simple imputer and scalar. Standard scalar really works. Yeah. Why? Okay, so and then I shall use parameters for CATBOOST and GPU. So it's simple to use GPU in training with CATBOOST, and it really works. And so yeah, and this pipeline with these oh, okay, I'll do it later. I'll check this later. And after grid search with these uh, parameters for learning rate, depth, and L2 leaf reg in a more simple way, because this will use this will be this will continue more than for more than 1 hour, and this stopped in 40 minutes. So the, sorry. So I'll use this for grid search, and some grid search for XGBoost to compare the results. So here is the CATBoost classifier with CB params. Where are they? Here are they. It was some other experiments. Okay, it's and I start and put the plots equal to true. So and it shows me the changing in real time. And when I used these grid parameters, the plot was like teeth. So it shows me that it has the best results on this step, where depth is 10, learning rate is 0.1, and L2 leaf reg is 7. It uses log loss. Okay. And here it writes also, and I can ask this model to give me its results, and here are all of them, and we can see that depth is 10, rate is okay, somewhere here. Where is it stuck? It's interesting. Mhm. Learning rate. Rate. Learning rate. Oh. So, and then not to lose time, I'll use the best of these parameters in my uh, teaching or start in teaching the model or teaching. So uh, I can save the model, I can load the model, and after loading, I can see some interesting statistics on each of. So I load the number of column of the feature, and I see how it influence on the result and how it distributes using the bins. Yes. So on in the intervals of its meanings. And of course, because I have only two uh, meanings of my targets, 0 and 1, the mean prediction is something between them. Maybe it can be useful. So I made an experiment. And where is score? The score is here. The score is here. So I didn't use here. Uh, did not use here. What I did not use here? I used here everything. I mean pipeline. No, there was no pipeline. So and there was no scaling. So I have to improve the result. Of course, it is not exactly correct, but I suppose that it's not Kaggle contest. uh, so after using XGBoost with XGB params scoring, okay, um, I've got the score of 0.8. Uh, so the second part, some testing of the scores. So I see that my lovely XGBoost that can work with categorical values shows worse results. Why, I don't know. Then I made some experiments and predicted one of the rows, number 11, and a CATBOOST showed me that it was 1 CATBOOST CB and XGBoost that it was 0. So let's use CATBOOST. So after that, I made some tests where I choose choose data set with ones, and it showed me that 800 values were not correct. False negative. Yes, false negatives. Mhm. And the same I did with XGBoost, and it is worse than CardBoost. So the same thing here. Why? Some experiments. Okay. Then I used pipeline with CatBoost. Why should I do this? Because it has a scaling part. Classify estimated preprocessor transformer numpype, and numpype uses simple imputer and standard scaler. Standardized features by removing the mean and scaling to unit variance. And the winner is scaling. Best params, and of course this training was faster in 10 times, and it showed better score, better, but not much, but 8106, 8124, better score. Okay, some experiments, and this does not differs 845, and here was 800, but it's better. It's better. So, and then I made an experiment to not to use some code to multiply the number of dataset values. It's not good. I used the method called compute class weight. So uh, again, I made different train and test data sets, and then I use this what I have balanced, what what else I can use or none. If balance class weights will be given by by this formula, okay. So it gives me the array, and from that array I have to use to make a dictionary and put here class weights. So it automatically um, estimates weights concerning of distribution of target values. Whoa. Estimate. Estimate. And then I use this, and I've got the score of this meaning. Why it is worse than the previous score? Because in scoring it uses not correctly distributed data set. It has the proportion of the targets classes 1 to 3, and but if I use the proportional, no, the same amount of zeros and ones, I've got phenomenal score, phenomenal in my experience score of 0.88. Okay, maybe it can be not correct, but it's a fact. But this is not good. So, maybe good, better to use this than some code. And class weights can be inputted in input, can be put like in this dictionary simply, and also it shows and here is 1 to 3, and it shows worse 0. Here is 0.77, but here is 0.79, but here is okay. Very interesting. I suppose that every data set will have its own results. So in the next videos, some comments here. I'll do experiments with oversampling and undersampling data. So thank you very much for watching. Very glad to do this. Thank you. Bye. Hugging face. Thank you.